Welcome everyone to the first Process Safety with Louise. I'm going to share the screen, so let me know if you can see it in the chat box. Okay, as before, if you have any questions throughout the session, just type them in the Q&A and that allows me to answer them live. Okay, so we're starting this month with the first Process Safety with Louise. This is very similar to the Process Safety Forum. So I'm just going to go through the rule set again to make sure that we're all aware of what we're agreeing to here. This is being streamed live to YouTube and it will be available for playback on the YouTube channel. So just be mindful and respectful of others whenever you type something into the chat or ask any questions. So what is this session going to be? It's a place to get access to industry experts and ask questions on specific topics once a month. I'm doing a rotation now. Before we used to have a specific topic for the month, but I found that potentially that could be a bit restrictive and people wouldn't attend because they weren't interested in that topic that month. So you can join and you can ask questions on any process safety topic you have. We will still be having guests from time to time. So again, keep an eye out for guests and they'll be able to answer your questions as well. We're going to do a rotation on the timing. The first one is at 8 p.m., which is this month. Next month is going to be 7 a.m. and then the month after will be at noon. They're all on the first Wednesday of every month. And this should allow people from different areas to attend and to ask their questions live. It's available for catch up on YouTube and it's a place to share best practices. So not only will I be sharing information, but if you guys have best practices as well, please feel free to pop them in the chat or in the Q&A so that we can share them with everybody. Our aim here is to improve process safety worldwide, so feel free to share what you know. We're going to start the session now. So this is how it's going to run. We kicked off at about 8 o'clock. I'm going to run through an introduction and then I'm going to run through a safety moment. And the reason I'm doing this, it gives time people to join and also gives people time to ask any questions that they may have already had. So it just gives time to start the session. And I think also it sets the scene and allows us to learn from a previous incident, which maybe we haven't thought of for a little while. Then I'm going to open the floor for questions at about 10 past, and then we'll wrap up at about 10 to 9. Okay. So if anybody's having any problem hearing me or anything, just pop it in the chat and I'll be able to fix that. So welcome, an introduction to myself. My name's Louise Whiting. If you haven't attended the previous process safety forums, I am a professional process safety engineer running my own company called Barberton Limited. I provide professional process safety services, and I'm running this as a charitable endeavor so that we can share best process safety practices throughout the world. Okay. This month's safety moment is going to be Flixborough. So yesterday was the anniversary of Flixborough. It happened on a Sunday and there were 28 fatalities and there were thousands of buildings damaged. I'm going to go into a little bit more detail about what happened, but 18 of those fatalities were in the control room. So the location of buildings, in addition to other things that we'll learn tonight, was a critical factor into the number of fatalities on that day. So what actually happened? Well, a company called Nipro UK were manufacturing cyclohexane as an intermediate for nylon. Okay, they did this in a 6-stage reactor process, which was a reaction done in series, and they added hydrogen into the reactors. It was done at high temperature, 155 degrees. And a couple of months before the incident, they had an inspection of reactor 5, and they found that there was a big crack about 1.5 meters along one of the pipes. And so they decided that they needed to take reactor 5 out of service to be able to repair the crack. Now, obviously, while they were repairing this reactor, because it was reactors in series, they were unable to produce the intermediate needed for their nylon production. And so the engineers worked on a temporary solution. And they installed some temporary piping between reactor 4 and reactor 6. So I've got a couple of pictures here to help us understand what happened. So you can see here is reactor 4 and here is reactor 6. You can see where reactor 5 has been removed. And what we're basically doing is connecting reactor 4 with reactor 5. The way that the reactors were staggered was to allow gravity flow between each of the reactors. So there was a height difference between reactor 4 and reactor 6, which would have allowed gravity flow to reactor 5 and then to reactor 6. The engineers decided that they would install a pipe in between, and you can see here the scaffold is how they intended to replace reactor 5. And they supported this pipework on the scaffolding, and they installed bellows at either end of the pipework. And the thinking behind this was that there may be some movement in the pipework, and so therefore the bellows would be able to move, ensuring that there, we didn't have loss of containment because of a fatigue. And you can see here that you had a weir where the liquid come out of reactor 4, flowed down into the pipe, and then it went into reactor 6. Okay, and you could see this dog leg here. So they were starting up the system. The engineer who was involved in designing the change was on site at the time. And as they started to operate, they started to get some stress at the bellows. Okay, and as the stress became worse and worse, the bellows ruptured, and they released several hundred tons of cyclohexane, which formed an enormous vapor cloud. It found an ignition source, and they think that that was the furnace on the facility. And when it found the ignition source, it became an explosion, and that is what caused the significant damage to the buildings in the area. It almost flattened the control room, and as I mentioned, there were 18 people in the control room. I believe there was a further 9 people on the facility, and then some members outside the facility were also fatally wounded, totaling 28 fatally injured in this incident. Okay, so the root cause, there are many causes for this, but one of the causes that has been identified is that the management of change was not reviewed by a multidisciplinary team. Now, if you've joined some of the previous master classes, we talked through the T2 reactor example. And again, this is the same thing that happened there. And this happened more than 30 years later than Flixborough. They implemented a change at T2 and they implemented a change here. And they had a single discipline engineer review the change. And if they had had a mechanical engineer review this change, they may have been able to identify this potential for the fatigue on the bellows. Okay. So that's the end of the safety moment. If anybody has any questions, you can pop them into the Q&A and I'll be able to answer them. But one of the things that has been coming up quite a lot today, this week on LinkedIn, is the use of risk matrices. And I think the statement was that if we are using risk matrices to help us make decisions, then we are damning us all and we shouldn't be using them. I agree that risk matrices can be abused and very easily used inappropriately, but I have seen on several occasions risk matrices really help us decide what to do next and where to put our resources. The basis for using risk matrices in a really good way is to really understand the hazards at your facility. So understand where your hazards fit in on the risk matrix. So making the risk matrix a bit personalized for your location. I don't know if anybody else has had any experience in this, but what I've seen work really well is where, for example, you say a severity 4 is loss of $5 million. We could have examples there of a lost production for up to a week, or we could have a loss of major equipment such as one of the separators or one of the compressors. That could be classified in that band, and then we might put another definition for the band above. And that really helps us keep consistent in all of our meetings and helps us manage the risks and the resources to tackle the gap closure for different risks. Another thing that was discussed on this post on LinkedIn was that we seem to have a lot of risks which fall in the middle. Very few risks which are high frequency, low severity, and very few risks which are high severity, low frequency. And I think that this is, and then they said that this is maybe not how life is. But actually, if you're thinking about a high hazard site, this probably is how life is. So you'll see an overlap of personal safety incidents, which will be the high frequency, low severity. And then there'll be some in the middle, which have a bit of a higher severity, but a lower frequency. And then the process safety incidents will be coming on the other side of the matrix, and they will have the high severity, low frequency. Okay, and so you will have these two outliers and then quite a large number in the middle, because you're having two different types of events which are overlapping in the middle. Okay, I haven't had any questions yet, so if any of you have come here to ask any specific questions about things that you are experiencing on your facility, or things that you have seen that you have some questions about, please pop them in the Q&A and I'll be able to answer them. Okay, I also haven't had anything in the chat. I'm hoping that you can all hear me. If you just let me know in the chat. Another thing that was quite well discussed this last month on LinkedIn was my post about Piper Alpha. And if you haven't seen that on LinkedIn, I would encourage you to go and have a look, because I think that gives the stark reminder as to why we do process safety studies, why we put focus on these high severity, low frequency events, because a lot of the stories that we saw on the comments there are giving the sort of human aspect to the process safety, which is helping us remember that what we're doing is keeping people safe every night, making sure that they can go home to their families. So if you didn't see that post, that's a really good post to have a look at. It also has a video on Piper Alpha. Another thing that we're seeing a lot of on LinkedIn at the moment are dust explosions. And this month's process safety sheet from the CCPS is on dust explosions. So I don't know if you might have seen George's post this week on that. If you haven't, have a look at that. And then I also posted last week a couple of posts on dust explosions to help you identify some ways in which to reduce dust explosions, both in the design and the operate phase. One of the articles was related to the to the new biomass. So there's a lot of new biomass facilities coming out. And obviously these facilities have a hazard of dust. And because the facilities that are being installed are going to, in some cases, be new technology, there is a chance that the sort of old hat, the old risks are not paid as much attention to as they should be. And so therefore, there is a potential that we might be missing the dust hazards. And in a few years' time, we'll see an increase in dust hazards. A lot of the dust hazards that we've seen being realized are in workshops and storage areas. And I wonder if that's maybe because there have been less people in the facility and maybe less housekeeping has been happening. And so as a result, we're having a lot more dust accumulation because we have less people being able to keep the place tidy, which they would have done before COVID. I don't know if you want to share your views on that in the chat or in the Q&A. I'll give you guys a moment to be able to type some questions in. So has anybody had or Want to share any experience associated with the example that we saw? Had you all heard of Flixtra before you attended tonight? Was there anything that you learned new which you didn't know about the Flixtra incident? How is your management of change process on your facility? Do you need any help with that? So I'm giving you guys this chance to ask me any questions if you have them. And also, if you ask me a question I don't know the answer to, I can connect with my network and get you the answers. If there's not too many questions tonight, we can wrap up early. But I'd like to give you guys an opportunity once a month to ask questions about process safety to try and help improve your practices on your facility. So if you do have any questions, I'm more than happy to wait until past and I will happily answer those. And if not, then we'll wrap up and we'll catch up again next month. Another one of the things that is happening recently is that we're all returning to work after COVID. And I have seen an increase in the number of road traffic accidents recorded in the US and the UK, despite the number of driving hours significantly being reduced in the last year. I think when you guys return to work, I think what you need to remember is that you are not operating at the same level that you were before. And so your awareness of the hazards on your facility may not be the same as what they were before. And so there is a potential that we have an increase in process safety incidents just as we start going back to work now, if you've not been in the office for a long time. And it also might be an increase in personal safety incidents. So I've had a question in asking a little bit more about dust explosions and hazardous error classification and which code we can use. So I know that you can use the DSEER code, and I know that there's a really great guy on LinkedIn who has the answer to all of these questions. You know, you need to be looking at the size of your dust, the flammability of your dust, what the distribution is, if you have an enclosed space or not enclosed space, and how to enclose and how to then have a look at the EX equipment. So what I'll do is in the follow-up email from this webinar, I will send you guys a link to, there's 2 people online who have really good competence in dust explosions. And I'll send you a link to both of them so that you guys can get in touch with them if you have any specific risks. The main thing to do is to try and make sure that in addition to controlling your ignition sources, if you have any enclosed area, to make sure that that is appropriately zoned, and to make sure that there's no surfaces upon which the dust can accumulate. So a lot of the facilities which are seeing incidents are legacy facilities. And so the surfaces which are high up in the rafters, they have flat surfaces. And so as a result, over time, the dust can accumulate on that flat surface. And then if there's any disturbance, that then makes a really big cloud for dust explosions. And dust explosions are not limited to the process industry. There's the metal processing industry, where you make pillows, where you process cotton. All of those have really high dust hazard because they have flammable dust. And some things which maybe are potentially more difficult to ignite when they are in their solid form can be quite explosive in the dust form. So I'll send that in the follow-up email from this event. Okay, I have another question, which is if a mechanical equipment needs to be changed, will the management of change authorization involve people from other disciplines? So I think it depends on how you manage change at your facility. If the mechanical equipment is being changed for the same model type, with the same function, and there's absolutely no change to the equipment, for example, you know, it's been wear and tear and you are replacing, say, a seal, or you're replacing a like-for-like pump, then you may not need to complete a management of change. There will be a record of the change of equipment so that you know that you're using a new serial number and what date it was changed on. And that will probably be managed through your SAP process or your maintenance process. Most of the time, though, we find that when we go to replace equipment, we've actually been using it for so long that we are unable to replace it for the same thing that we were using initially, because that has become obsolete. In this case, you definitely would go through a management of change. Now, sometimes when you're going through this management of change, you might decide that it's a single discipline change and you may not need to include other disciplines. But the approach that I always take is that during the screening phase, where we're discussing what the change will be, how it might change the process, etc., or maybe some of the instruments, it might change the instrument connections or the communication with the instruments. When we're discussing that change, we have a multidisciplinary team available. Now, if those engineers who are in that team decide that this is not something that they need to be involved in, it's a single discipline change, you can declare it at that point. But if you are doing the screening as a desktop exercise with a single engineer, or as a manager without a multidisciplinary team, then you may get yourself into a situation where you make a change and it actually has more significant consequences than you may realize. So an example of this was we put in a pump so that we could pump out some liquid which was accumulating in a gas pipe. And we did this as a temporary arrangement. However, we couldn't, during the time of operating it, think of a different way of removing the liquid from this pipe, i.e. we couldn't think of a different way of making sure there was less liquid in the gas. We couldn't think of a different way to make sure there was less condensation. We couldn't think of a different way to accumulate this liquid somewhere else. And so therefore, this pump stayed in service for quite a long time. The original management of change was conducted by a single discipline because it was seen to be just a process change. However, because the pump was staying in there for quite a long time, it was realized that there was some mechanical aspects to this and also some instrumentation aspects to this. When the mechanical engineers had looked at it, they found out the way it was installed introduced high stress onto the hoses, and then we took corrective action, and that was fine. We caught it before there was an incident. But if we had had the mechanical engineers involved in that first step, that screening of that change, they may have involved themselves in that change before we got to a situation where we had installed something with high stress. So definitely, if you're making a change, I cannot say definitely whether it will be one discipline or will be several disciplines. But if you use a screening process where at the first step for a change, you have a multidisciplinary team, that is your best chance at being able to involve the right people at the right time in your change. So I hope that has answered your question. Okay, does anybody else have any other questions on process safety, on the application and management of change, HAZOP, LOPA? Is everybody still doing virtual HAZOPs, or have you started to do face-to-face HAZOPs now in your facility? And are you finding it a lot different coming back to face-to-face HAZOPs if you are doing those? I know I'm getting increased requests now for face-to-face workshops within the UK, obviously because the travel is still restricted. There's not that much demand for outside of the UK, but inside the UK there's requests. So I can definitely see that some people feel that the remote HAZOPs are not giving them the same level of discussion or engagement as the face-to-face ones. I think also that depends on the facilitator. A lot of the facilitators are really, really great at managing a team face-to-face, but potentially with the changeover to the virtual setting may have not adapted that well to a new way of working, especially if the scribe is remote. That can introduce some communication problems as well, which may impact the outcome of the session. And also I know people get very distracted if they've got their computers open and all their emails, and so therefore they might not be actively participating, and it's very difficult to tell on the online session whether people are actively participating. Okay, well, if there's no more questions, I'm going to go on to wrap up the session, and if any questions come up during the wrap up, I'll happily answer them afterwards. And if not, I will see you guys next month. Hopefully you guys will have more questions. Perhaps I just answered all of them before you had any time to ask them. Okay, so just going back to the presentation. So what's coming up this month? So I've got a couple of courses online, which are HAZOP, MOC, and Process Safety Metrics. So the HAZOP course will give you an opportunity to participate in a HAZOP workshop to see how different people's roles are and what good recording would look like in accordance with the international standard. The management of change, we are doing that in 3 separate workshops. So we're covering what I've discussed tonight, which is the screening and the initiation, as well as the risk ranking. That will all go into one workshop, and then we'll be discussing the final 3 phases in 2 following up workshops. And then process safety metrics, we'll be having a look at 2 different examples to allow us to look at how we can apply the HSC guidance on process safety metrics. That's HSC 254. To have a look, and we're going to be trying to challenge ourselves to look at leading indicators and figure out how we can make better the assessment of process safety incidents before they happen, so we can start to catch a lot more things before they fail. And then we're going to have the next session for this is on the 7th of August at 7 a.m. UK time. Okay. And that's all I have for today. So if you guys have any more questions, feel free to ask them and I will answer them. I'll stay on for another 10 minutes. And if you don't have any questions, that's fine. I'll see you guys next month. One of the other things that I've been getting asked a lot of questions on is if I want to develop myself, what's the best way to do that? And so a lot of people have asked me about the different process safety courses at university in the UK. The Aberdeen one, there's one at Sheffield University, and then there's a few others in the UK. And then also there have been a lot of questions about the NEBOSH and the Certified Functional Safety Expert or Certified Functional Safety Practitioner. Nick, Howard and I did a webinar maybe three months ago on careers. And if you haven't seen that webinar, I'd strongly recommend you having a look. Nick has got some really great tips about changing your career or looking for a job as an engineer, because he used to be an engineering recruiter. So he used to recruit process safety positions. And then also in that video, I talk about the different courses and about how to identify which thing that you want to do, which course you want to do based on where you want to go. So a lot of people ask me if they should do the Certified Functional Safety Expert. And I say, well, are you going to become a HAZOP facilitator anytime soon? And they go, oh no, definitely don't want to be a HAZOP facilitator. So the question is, why are you doing that course? A lot of companies look for Certified Functional Safety Expert when you are wanting to do HAZOP facilitation or other workshop facilitation, but they don't necessarily look for Certified Functional Safety Expert when you are applying functional safety, which maybe is not the right way, but that's the way it is at the moment. However, the certified, Nick Cottrell, sorry. And the Certified Functional Safety Practitioner may be the better one for you to do, because that gives you a really good overview of the international standard without having the really onerous requirements of the of the functional safety expert and all of the career requirements that it has. So if you have a look at that webinar, Nike's just reminded me that it's Nick Cottrell, not Nick Howard. They both work at Six Engineering, and I often get confused on the surnames. Nick Cottrell has previously been an engineering recruiter, and he also posts quite a lot of jobs on process safety on LinkedIn. So if you're looking for something, Nick sometimes comes across things and posts those on LinkedIn. So if you're looking for a job, if you're looking for a job, have a look at Six Engineering's posts, because they post jobs from other companies as well as their own. And okay. So if nobody else has any other questions, I will wait. I've got one more in the Q&A. Let me just see if I can get that here. Okay. Any courses or certifications to enhance competency in carrying out QRAs? So this is a really good question. The qualification that I did to help me with the QRAs was the Major Accident Hazard course for BP. And that trained me on GP 4850, which was to look at a very specific way of doing QRAs. So BP has a very consistent way of doing QRAs for a specific purpose. And then you can conduct a QRA for other purposes, for example, for regulatory compliance, and there may be some more freedom in the numbers that you use. Courses to enhance competency in QRAs, I haven't seen any specifically, but I would start initially with something associated with consequence development. And if you have a look at any of the Spade-Adam courses, those would be really good courses to help you understand the different consequences that can happen, how you can get different events. So whether you can have a flash fire, a pool fire, a vapor cloud explosion, a BLEVE, etc. So that helps you identify all the different scenarios, which is really important. And then also those courses can help you understand the consequences. So understanding the fatality probability from a flash fire, and whether different types of buildings can get damaged as a result. The best way to learn about QRA is to do them, but under the guidance of somebody who is competent. I think there might also be an ABB course on QRA, but I'd have to have a look. So I'll have a look for you to see if there's either an ICME or an ABB one. And I've got a comment here to say that RISTech may do a QRA course as well. But definitely start with consequence modeling to understand what different types of consequences there can be, what the limitations of the different modeling are. And then once you know the different scenarios, you can start looking at building your event tree, your fault tree, and leading onto your event tree so that you know what the consequences are. A good course that just talks about the high level about QRAs is the Process Risk Assessment course for the ICME, and they explain a really consistent way of applying QRA. So when you buy a QRA, you can buy two types of QRA. You can buy a generic QRA, which uses generic numbers and generically assumed piping lengths and generic consequences and generic scenarios based on your type of plant. And then they adjust that for your layout, okay? Or you can specifically use your hazard, your HAZOP, and the APRA of your LOPA to build fault trees and event trees, and then build those into your layout in the QRA. And that's a much better way of getting a representative result for your facility and what your hazards are. The other way, you kind of get a picture for, could be your facility, but it could also be a facility which is very much like yours, but not yours. And so therefore you may be over or underestimating your risk there. Okay, so the process risk assessment course from the ICME gives you a high level, but for more detailed, I think we've got one here from RISTech, and then also looking at the courses from Spade-Adam on the consequence analysis. Okay, well, thank you all very much. have a wonderful month, and I will speak to you in a month's time at 7 a.m. Where I can answer more questions, and I will share another safety moment which we can discuss if necessary. But again, you can learn from a previous incident. Okay, thanks very much everyone for attending. I'll see you next month.